geochemical fingerprinting of dust. This image, the orange plume that you see in this image is the dust going around the globe. So it's a famous dust belt. It's called the Asian African dust belt. And this dust will reach us in the United States, although it's originated someplace in North Africa and Middle East. And also this dust can be reached in North Pole and also from Australia to Antarctica. One of the issues in study of the dust movement is which part of these dust sources are active during what part of the year, and how the atmospheric circulation can activate and emit the dust from these dust pools. And to be able to study that, there are different techniques. And one of the easiest one is to go and look into the satellite images, but normally you don't have satellite images for dust event at the same time which is happening. And sometimes these satellite images, they not only doesn't have like the right overlap, but also that the image of the dust plume is so complex that you cannot pinpoint the plume to a source. In this case, by knowing the composition, isotopic composition of the source, we can isolate the source of the dust, which we are receiving, for instance, somewhere in Caribbean or in the United States or in the North Pole. So here is an example. I took these graphs from the paper that I published in 2018. On left-hand side, you see the epsilon hafnium versus epsilon neodymium, and these are different arrays. And you see the different dust pools, how they separated beautifully on this plot. And you, of course, you have some overlaps, but in general, these isotope systematic did a great job with isolating different dust pools. So technically, the dust pools from the Chinese loess are different from the Central Asian orogeny belt. And they are different from the sea spray from Atlantic seawater. On the right-hand side, you see how different major dust pools in the world are aligning with respect to the epsilon neodymium and strontium. Yes, again, you can see tons of overlaps, and this is why we are using multiple isotopes. So we don't rely on only two systematics. We would like to analyze these. So in this case, I was able to isolate the modern dust from the Middle East, from Iran and Iraq, the dust from North Africa and Morocco. And also I was able to isolate the paleo dust. So this box refers to the paleo dust, which I measured and characterized, but the rest of the graph represent the modern dust sources.